Welcome back to the Deep Dive, where we take your stack of sources and give you that essential knowledge shortcut.
Today, we are plunging into a topic that has just generated massive buzz in the health world.
Radish microgreens. They're tiny, they're spicy, and they are everywhere online, marketed as a nutritional shortcut, promising everything from liver detox and anti-aging magic to, better metabolic and cardiovascular health.
And our mission, based on the material you shared, is to really act as your expert filter here.
Right.
We're going to cut through all that consumer hype and figure out what, among these pretty fascinating claims, is actually supported by high-quality human clinical evidence.
So we're talking randomized controlled trials, systematic reviews.
Exactly. Versus what's just based on some exciting but, preclinical data from test tubes or animal models.
So we're drawing a hard line. Hype versus actual verifiable proof. Because it really matters where you choose to spend your attention and your money.
Absolutely. And let's just state the core finding right up front so we're all on the same page.
Okay, let's hear it.
Despite all the enthusiasm and some genuinely robust preclinical interest, high-quality human clinical trial evidence, specifically on radish microgreens, for major clinical outcomes like longevity, cardiovascular health, mental well-being, it's just strikingly absent.
So basically, all those claims you see online for specific health benefits.
Almost all of them are currently rated very low or insufficient in terms of clinical evidence quality.
That is a crucial finding to get out there right away. But it does beg the question then, why all the hype in the first place?
Right.
Let's start with the chemistry. Why are these tiny plants harvested just, 7 to 21 days after they sprout considered such a powerhouse?
Well, it comes down to basic plant biology, really, and concentration.
Okay.
When a seed first sprouts, that little seedling is designed to have all the defense mechanisms and stored energy it needs to survive.
It's packed for a long journey.
Exactly. Radish microgreens are like these tiny biosynthetic factories. They pack key bioactive compounds into a very small space, concentrating them, often 10 to 100 times higher than what you'd find in the mature radish root.
10 to 100 times. That is a staggering difference.
It is.
So what are the specific star players here that get researchers so excited?
The main focus is on these sulfur-containing compounds called glucosinolates.
Glucosinolates. I think I know those, even if I don't know the name. They're the compounds that give radish and mustard greens that really sharp, pungent flavor.
But that's them, exactly. They're basically nature's chemical defense system. In the radish, the specific one is glucoraphacetin, and that's the precursor to the really active compounds, the isothiocyanates like sulforaphane.
And that conversion is the engine behind all this.
That's the engine. It's the key to everything.
Okay, so beyond those spicy defense chemicals, what else is packed in there?
Well, we also see incredible levels of polyphenols, including anthocyanins.
Which give the red varieties their color.
Precisely, like in red Rambo. And you also have various quercetin derivatives. Then there's the vitamin punch. It's undeniable.
How big of a punch are we talking?
Some sources show the vitamin C content is up to 6 times higher than what you'd find in, say, mature red cabbage.
Yeah.
Plus, they're dense in vitamin K, folate, vitamin E, and important carotenoids like lutein, which is vital for eye health.
So the plant itself is, it's undeniably a micronutrient powerhouse. But does the cultivar matter? Or is one radish microgreen basically the same as another?
Oh, cultivar matters significantly. If you're looking for the antioxidant power of anthocyanins, for instance, you'd want varieties like Red Rambo or Asia Red. They have superior levels of those pigments and vitamin C.
And other types.
Conversely, if your interest is more in, say, fat-soluble vitamin E or different types of glucosinolates, you might look toward Daikon varieties. The phytochemical profile is highly sensitive to the seed.
Okay, that gives us the context for all the excitement. Now let's pivot hard. We need to move from what the plant contains to what the plant actually does in a living person.
Right. This is where we have to put on our skeptical hats.
So when we're evaluating health benefits, we have to look at the evidence hierarchy. The gold standard is what?
It's the randomized controlled trial, or RCT. That's where participants are randomly assigned to get either the intervention or a placebo. Yeah. Then we look for systematic reviews that pull all those high-quality trials together.
And as you said at the start, when we search for those specifically for radish microgreens, for things like preventing heart disease or fighting inflammation, what do we find?
Zero.
There's zero.
We find zero, which means that all those claims you see online, they're based on extrapolating from studies on maybe related vegetables, or worse, just from test tube studies.
So the evidence for those big clinical outcomes is
robustly rated as very low or insufficient.
But if the preclinical data is so compelling, Why aren't institutions or, government bodies funding these big human trials? Is it that they aren't patentable?
That's the perennial issue with nutrition research. You can't patent a radish microgreen.
Right. No financial incentive.
None for the pharmaceutical industry to fund multi-million-dollar RCTs. And look, studying food is just complex. You have to account for diet, preparation methods, individual variations. It makes a large-scale trial extremely expensive and difficult compared to testing a single pill.
That structural reality explains the gap. But you did find one sort of indirect piece of human evidence that gets cited a lot.
Yes. The one study was an open-label pilot study from 2014, and this is key. It did not use radish microgreens.
What did it use?
It tested a concentrated Spanish black radish supplement in tablet form. So think of it as a chemical cousin, not the food itself.
Okay, and how did they run this study?
It was small, just 19 healthy young men. They took 6 tablets a day for 28 days, and the main goal was to look at markers of liver enzyme activity, specifically detox pathways.
And what did they find about liver function?
Well, they found results that were consistent with an upregulation of both phase 1 and phase 2 liver detox enzymes.
How did they measure that?
They gave the participants acetaminophen and then tracked how their bodies metabolized it. They saw a pretty significant drop, about 40% in the amount of unchanged acetaminophen in the plasma.
Meaning the body was processing it much faster.
Much faster. They also saw a decrease in a general liver enzyme marker, GGT.
So the supplement was definitely doing something. It was chemically active.
It was. And here's a finding that often gets overlooked, which leads us to our safety cautions later on. They also noted a decrease of about 10% in estradiol 17-8.
So it affected hormone metabolism too.
It modulated hormonal pathways, yes.
But let's really drive home the limitation here. This is a synthetic supplement, not raw food.
Precisely. And it was a small, short, open-label study. Everyone knew what they were taking, and it had no placebo arm. You can't rule out bias.
It's hypothesis-generating at best.
That's all it is. We simply cannot take these results and claim that eating a handful of raw microgreens will provide a clinical detox benefit. That's a leap the data does not support.
Understood. So now that we've established the lack of human proof, let's dive into the sheer potential. Why is the non-human, the preclinical data, so compelling to researchers?
Because the mechanisms we see in cell cultures and animals are just so logical and consistent.
How so?
For example, that detox finding from the human pilot study. It aligns perfectly with cell studies where Spanish black radish extracts induce those same phase 1 and phase 2 enzymes in human liver cell lines.
And in animals.
In mice models, these extracts protected the animals from model carcinogen toxicity, so the mechanism holds up across different models.
That makes a compelling case for the mechanism, even if the outcome isn't proven in humans.
Yeah.
What about the broader claims, like anti-inflammatory properties?
That's where we see robust data on antioxidant and anti-inflammatory activity. Rodent and in vitro studies show these radish compounds activate what's called the NRF2 pathway.
And what is NRF2?
Think of NRF2 as the master switch that turns on your cellular cleanup crew. And at the same time, they seem to reduce inflammatory signaling by inhibiting the NF-kappa B pathway, which is basically the inflammation siren in your cells.
So it's turning down the siren and turning up the cleanup crew? That sounds like a great combination.
A very promising combination, yes.
And the metabolic signals you mentioned.
Right. In diabetic mouse models, radish extracts improved metabolic endpoints. They showed anti-obesity mechanisms, better insulin sensitivity.
But, I sense a but coming.
But, and this is a huge dose of reality.
Yeah.
The doses used in those animal studies are often unrealistically high for a human to consume as food.
How high is unrealistically high? Are we talking about eating a bucket of microgreens a day?
Often, yes. To get the same effect seen in a small mouse, scaled up to a human body weight, you might need to eat several hundred grams of microgreens daily, maybe even a pound or 2.
So it moves beyond a garnish into a full-time job.
An unsustainable, heroic volume of consumption. And that's why translating animal results to human health claims is so problematic.
I also saw some sources touched on neurobehavioral claims.
That is entirely speculative. We have to flag it as such. Some rodent studies report what they call anxiolytic-like effects, a reduction in anxiety, maybe through GABA-A and serotonin receptors.
But for humans...
But translating these mental health findings from a mouse to a human is highly premature. It's not something anyone should rely on.
So if we strip away all the speculation, the core mechanism driving all this promise from detox to anti-inflammation, it all links back to that initial chemical conversion.
It absolutely does. The key pathway is always the same. Glucosinolate gets converted to isothiocyanate. The resulting compounds, like sulforaphane, are these potent chemical signals that induce those protective enzymes.
Okay, let's turn to the practical side, the potency puzzle. If someone listening chooses to include radish microgreens in their diet, just as a supercharged vegetable, how can they maximize that potential chemical benefit?
We have to focus on a critical plant enzyme.
Myrosinase.
This enzyme is the essential chemical scissor that converts the inactive glucosinolates into the active isothiocyanates. If you bypass myrosinase, you bypass the immediate potent health potential.
So how do we activate those scissors?
The raw rule is essential. The enzyme and the precursor are stored in separate parts of the plant cell.
So you have to break the cell wall.
Exactly. Chewing raw microgreen tissue is what physically ruptures the cells, releasing the myrosinase and letting it immediately get to work. That mechanical action is instantaneous and highly efficient.
I see. So if you cook them, you've cut the legs off your superhero before they can even run.
That's a perfect analogy. Heat is the great inhibitor. Cooking, blanching, anything above, say, 60 Celsius or 140 Fahrenheit, it inactivates that plant enzyme.
And how much of a reduction are we talking?
It can be drastic, as much as a 70 to 90% reduction in that immediate conversion. Now, gut microbes can compensate a bit later on, but it's generally far less efficient.
So keep them raw and chew well. Any other factors that might boost the benefit?
Yes, absorption matters. Consuming them raw with healthy fats like in an olive oil dressing, with some avocado, enhances the absorption of the fat-soluble vitamins, especially vitamin Z and K.
And you touched on this earlier, but does this conversion process work the same for everyone who follows the raw rule?
This is maybe the biggest variable. Bioavailability is highly dependent on individual differences,
Like what?
like the composition of your specific gut microbiota, for one.
Yeah.
And also genetic variations, like something called the GSTM1 polymorphism.
What does that mean for the listener?
It means some people are genetically just much better at metabolizing these active compounds than others. You and I could eat the exact same salad, and our bodies could have significantly different levels of bioactivity.
Which makes claims of a guaranteed universal benefit highly questionable.
Very questionable.
That leads perfectly into our final section, practical guidance and safety. Viewing these as a nutrient-dense food with exciting potential, what are the clearest evidence-based recommendations we can make?
For general nutrition, a food-based approach is safest. A practical goal would be including about 25 to 50 grams of fresh weight daily.
And what does 25 to 50 grams actually look like?
It's roughly a loose handful, enough to generously top a couple of sandwiches or a big dinner salad. It's an easily achievable amount.
And the non-negotiable preparation rule.
Consume them raw and chew thoroughly. Avoid expecting therapeutic benefits if you choose to cook them.
Okay, now let's talk safety. That pilot study showed changes to both detox and hormone metabolism.
Caution is definitely warranted, yes. Because that human pilot study showed modulation of phase 1 and phase 2 enzyme pathways, there are plausible theoretical interactions with prescription drugs.
Which drugs should people be most cautious about?
We'd need to caution those on drugs metabolized by CYP enzymes. This includes certain statins, some anticonvulsants, and crucially oral contraceptives.
And because of the hormone finding.
Since the study noted the change in estradiol metabolism, anyone on hormonal therapy should absolutely consult their doctor before taking concentrated extracts or really high, consistent doses.
We also have to address the high vitamin K content.
That's vital for patients on anticoagulants like warfarin. Microgreens are high in vitamin K, which can counteract the medication. The key is consistency.
So it's not don't eat them, it's be consistent.
Exactly. If you eat them regularly, you have to maintain a consistent intake and monitor your INR levels with your provider. A sudden large increase in vitamin K can be dangerous for these patients.
Any other concerns?
There's a theoretical concern about high glucosinolate intake and thyroid function, but only in people who are already iodine deficient. The sources agree that the clinical significance of this risk is minimal at normal food-based doses.
So let's synthesize this all into a final takeaway.
Okay. Radish microgreens are clearly a nutritional powerhouse. The concentration of vitamins, polyphenols, and those key glucosinolates is impressive.
And the preclinical evidence is robust and promising.
Extremely promising for their role as antioxidants and anti-inflammatories.
But the clinical efficacy for any specific health outcome, confirmed detox, anti-aging, mental health, it's just unsubstantiated by human trials.
Exactly. We have the proof of concept in the lab, which is exciting, but not the proof of patient benefit in real life. The critical research gaps are massive. We urgently need long-term human RCTs.
And dose-finding studies.
Yes, to translate that heroic animal dose into a realistic human dose. And we do direct comparisons between eating them raw versus taking a supplement. Until then, we just can't confirm that these fascinating mechanisms translate into meaningful, reliable human health benefits.
Which brings us back to that truly fascinating point about individual response. We've seen that the critical conversion, where the real power lies, depends heavily on your individual gut microbiome and your genetics.
The source material made that very clear. The vehicle is you.
So, if the power of this superfood is determined less by the food itself and more by the specific mix of bacteria and genes you carry inside you, what does that mean for personalized nutrition claims? And how does your plate change when you accept that your own biology is the final determinant of success?
That is something worth chewing on.
It certainly is. The future of nutrition requires us to look inward, not just at the label on the package.
Absolutely.
Thank you for navigating that evidence gap with us. Until next time, stay well informed.